I'm just going to talk you through the early stages of human visual processing in a very simple schematic. So, first of all, I'm just going to explain this diagram here. This is a diagram of a human brain with eyes and the lateral geniculate nuclei. Now we're looking above. This is a schematic diagram. Imagine you're looking down on the person, and you can see through the skull in what's called a transverse section. So with that in mind, it's fairly obvious that the person is looking forwards, where forwards is the top of the screen. The labels are fairly obvious as well. Now, in this next slide, what we're going to do is present a blue block. So the person is just looking ahead at a blue block that has suddenly appeared in the visual scene. And because we're looking from above, the blue block looks like a simple rectangle, and it's wide enough to make clear some of the subtleties of visual processing, and I'll explain these in this next slide. So again, just consider the blue block. In order to see this, what has to happen is that light will bounce off the blue block. So you've got a light source, it's giving off light rays which are bouncing off the object and into the backs of your eyes. And the eyes are spherical, and on the back of the eye is a photosensitive layer called the retina. So as soon as those rays hit the retina, they trigger off a series of processes, and basically you've got rods and cones in the back of the eye, and they convert light rays, light energy, into electrochemical energy, which is conveyed in the nerves. So the retina connects to the optic nerve, and the optic nerve transmits that information to the brain. Now, let's just have a look at this, because I've treated the rays bouncing off the blue block slightly differently. The ones in red, let's have a look at those first. They're at the outermost edges of the blue block, and what happens is that they are seen by what's called the medial aspect of the eye. Now, what that means is that's the part of the eye that's closest to the nose. So you've got some light waves bouncing onto the nasal part of the retina and triggering a reaction which converts the light energy into electrochemical energy. Now, in our next slide, I'll just show you how that information is transmitted. It's a special case of visual processing in which the images and the information captured on the nasal part of the retina passes on to what's called the optic chiasm, which sits in the sella turcica, which is where the pituitary gland is situated. And what happens here is that in some cases where people have a tumour in the pituitary glands, they get a compression of the optic nerve in the optic chiasm, and they get a resulting deficit in their ability to see at the edges of the field of vision in what's called a bilateral temporal hemianopia. And what happens next is that the information from the right eye passes to the left lateral geniculate nucleus, and the information from the left eye on the nasal part passes to the right lateral geniculate nucleus. Now, moving on to the next slide, we can see what happens to the light waves bouncing off the object in this at the center of this object. Now, these light rays will bounce into the lateral aspect of the eye and the lateral aspect of the retina. And in our next slide, we can see that these the electrochemical energy, the information, is being transmitted again directly to the lateral geniculate nucleus on the same side. So already what's happened here is that depending on where the information is coming from to land on the retina, it's being partitioned off into the medial and lateral parts of the retina. Information that are being partitioned off into separate streams in this early part of the visual processing. Now, in the next slide, we've got all the information in the lateral geniculate nuclei, which is passing in the optic radiation, and that's this next stage where the arrows are displayed in red. Now, once they pass into the visual cortex, the occipital cortex, this is the next stage of a fairly sophisticated processing, which is still considered to be an early part of the visual processing system. But by this stage, it starts to get quite complicated.